दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. We have discussed what is an oxidizing agent. Now we'll come to what is a reducing agent. Those substances which bring out reduction and get oxidized during the process of reduction are reducing agents. Just like the oxidizing agent, so agent is employed for purpose. So those substances which bring out reduction and get oxidized, they will bring out reduction and get oxidized during the process or during reduction are called reducing agents. So what is reduction? Removal of addition of hydrogen. So those substances which can add hydrogen, nascent hydrogen, they are very good reducing agents. So substances which are source of nascent hydrogen are capable of contributing nascent hydrogen during reduction are reducing agent. Since they are losing hydrogen, loss of hydrogen is oxidation, hence they undergo oxidation. So that's the reason we say the reducing agent is one which brings out reduction and get oxidized during the process. So they will substances, what is the reduction? Addition of hydrogen is reduction. So hydrogen will come from where? Will come from reducing agent as nascent hydrogen. So the reducing agent is losing hydrogen. So it is losing hydrogen. Hydrogen is removed from reducing agent. Hence it is reduction. Removal of hydrogen is oxidation. Hence reducing agent gets oxidized during the process. So then, who are the substances? We can give the example. Now, so the substances, those substances which can contribute nascent hydrogen to bring out reduction are useful reducing agents. So as they lose nascent hydrogen, so hydrogen is lost by them, hence they are undergoing oxidation. Example, now if you can say examples of hydrogen sulfide. So this can give us 2H, 2 nascent hydrogen and comes out. So this nascent hydrogen is coming from where? From hydrogen sulfide. So when the chemical reaction is going on, hydrogen sulfide can give us 2 nascent hydrogen to bring out reduction. So it's a very good reducing agent. Or if you take zinc plus sulfuric acid. If you take zinc, so we'll get zinc sulfate and 2 nascent hydrogen. So zinc, whenever we want to bring out any reduction, we can take zinc, add sulfuric acid, the reduction will take place. Or we have hydrogen peroxide, H2O2. So this can give us 2 nascent hydrogen and become O2. So somebody may question, sir, why this Now because you see, how is oxygen here? The oxygen is in -1 state. And oxygen is, what is oxygen? Is an elementary gas. Somebody may question, sir, why hydrogen peroxide is reducing agent? Why it is a compound? Hydrogen has combined with oxygen to form hydrogen peroxide and stable. Sir, why it will give hydrogen? Now because I just told you, when you throw something up, it comes down. So always one comes to the elementary state is the most stable state for the element, elementary state, pure state. So in a hydrogen peroxide, what is the oxidation number of oxygen? -1. Oxidation number of oxygen is -1 in hydrogen peroxide. So what it will be interested to become 0. Nascent molecular oxygen 0. So it is a strong tendency to become 0. How it can become 0? By give 2H. By giving 2H. Hence hydrogen peroxide is a reducing. Somebody will question that explain hydrogen peroxide is reducing, is it? Now it gives 2 nascent hydrogen. Why it will give? Now it is giving. No. It has to give, so giving. It is not giving. Giving means why? How to give? Now because in hydrogen peroxide, oxygen, hydrogen is always +1. It is in +1 state, natural state. Hydrogen is +1, natural state. And oxygen is -1. It is gone to reduced state. So here -1. So it will become always tends to become 0. Hence it is a very good reducing agent. Then there are some substances, for example, oxalic acid. Oxalic acid, we have taken oxalic acid is a very good reducing agent. H2C2O4. This is oxalic acid is a reducing agent. Why? Now it can give us 2 hydrogen here. The oxalate ion can give us 2 hydrogen here and it can give 2 nascent hydrogen to bring out oxidation and form 2 CO2, carbon dioxide. So this nascent hydrogen come out and bring out oxidation. We have done while balancing chemical equations. I have taken potassium permanganate and added oxalic acid and I've done the partial equation there. So there the oxalic acid is an reducing agent. Now if there are some compounds in their aqueous solution, they are very good reducing agent. They don't have nascent hydrogen. They don't have nascent hydrogen to give, but very good oxidizing agent. Why? There are some substances in their aqueous solution. In their aqueous solution, they are capable of giving nascent hydrogen. They are capable of giving nascent hydrogen. They are oxidized. They are very good reducing agent. Example, we will take sulfur dioxide is a reducing agent. Sulfur dioxide. Suppose the question will come to us. Sulfur dioxide is a reducing agent. So there is no nascent hydrogen it will give. It has no nascent hydrogen. How then? Now because if you take sulfur dioxide in presence of water, it forms sulfuric acid and 2 nascent hydrogen. One molecule of sulfur dioxide dissolves in 2 molecules of sulfuric acid to form H2SO4 and 2 nascent hydrogen. Hence sulfur dioxide is a very good reducing agent. We have seen the case of potassium permanganate. We have done the case while balancing chemical equation. I have taken potassium permanganate. I have produced sulfur dioxide. As passed sulfur dioxide through potassium permanganate, the color of potassium permanganate decolorized. I have shown you the reaction. So there, how the reaction took place? Then because sulfur dioxide dissolved in water and produced nascent hydrogen. That nascent hydrogen reacted with nascent oxygen of potassium permanganate and got neutralized. And the reaction took place. And sulfur dioxide is a very good reducing acid. So now we'll come to, then what is this? So if you come to electron concept, if we come to the electron concept, then how we define reduction? What is reduction? If you come to electron concept of this reducing agent. somebody may question me, sir, why you are coming to electron concept? Now, because first the chemistry started. Atom is the smallest particle of an element, may or may not have free existence, cannot be subdivided, is responsible for all chemical reactions. This was the thing about the atom, and science started growing from 1805 and went on to almost 100 years. Towards 1900, the discovery of electron came. Then 1905 to 1908, the Rutherford established the structure of atom. The electrons are the negatively charged particles are moving around the positively charged nucleus. The nucleus consists of the protons, where entire mass of the atom is concentrated. So these electrons, they are the fundamental particles, are moving and responsible for chemical reaction, was concluded by whom? By the Kosel. During the chemical combination, atoms of all elements have a strong tendency either to lose or gain electron to attain octet, to attain chemical stability, because an atom of the element takes part in chemical reaction to attain chemical stability. And we are discussing about chemical reactions. So who is the particle taking part? The electron. Who are the electrons? Now the electrons are the soldiers in the border of a state. In the border of the state, the soldiers who are there, they take part in fighting, securing the country. Exactly, the electrons present in the outermost cell are called as valence electrons. The electrons present in the outermost cell of the atom of an element are valence electron. They take part in chemical reaction. Hence, every chemical reaction, the property of every element, the property of every compound is explained according to the electron. So, and that is hence we come to electron concept. Now, what is reduction? Suppose X is the atom, and when addition of electron is reduction. This is called reduction. Why? Now, because decrease of positive valency or increase of negative valency is reduction. What is reduction? Decrease of positive valency or increase of negative valency is called reduction. So, how the negative valency will come? If you add electron. So, reduction is a process which involves addition of electron. Reduction is a process which involves reduction of addition of electron. So, where from this electron will come? This will come from where? From the reducing agent. This reducing agent will bring out reduction to get this X minus in the reduced state. Who did it? This is reduced state of the element X. Who does it? Now, reducing agent. So the reducing agent must be losing this electron. This electron is coming from where? From the reducing agent. So the reducing agent is losing electron. So any ball loses electron, loss of electron is oxidation. Hence reducing agent undergoes oxidation. So reducing agent undergoes oxidation. So the reduction is a process, reducing agent is a substance which brings out reduction and gets oxidized. Why? The reduction is a process of addition of electron. The electron added during the process of reduction is lost by the must have lost by the reducing agent. So reducing agent is defined as the substance which adds electron or loses electron during the process of reduction and gets oxidized. So we'll write the definition. Electron concept, the reducing agents. How we will define? The reducing agents are the substances substances which are capable of losing electron to bring out reduction and gets oxidized during the process. So this is the I am not remembering any definition. I wrote the reduction, and from there I got reducing agents are the substances which are capable of which are capable of losing electron. The reducing agent is losing electron, capable of losing electron to bring out the reduction and gets oxidized during the process. So that means what? Those substances which are having a tendency to lose electron are very good reducing agents. So the substances, which have a tendency to lose electron are good reducing agents. Good reducing agent are good reducing agents. So who are they? All the metals of group 1. All the metals of group 1 have one electron in their outermost shell. So inert gas, who? Helium. Then after that you have a lithium. Then comes a neon. After that we have sodium. We have argon. After that we have potassium. We have krypton. After that we have rubidium. And we have xenon. After that we have cesium. All these electropositive elements, all the elements of group 1, they have one electron. They can lose one electron and attain octet. Hence all alkali metals are very good strong reducing agents. That is rhodium, sodium is used as a very good reducing agent. So we'll say that all substances capable of tendency to lose electron are good reducing agents. So all electropositive metals are good reducing agents. So if you have lithium, sodium, potassium, rubidium, they are good reducing agent. If you come to zinc, magnesium, calcium, strontium, barium, zinc, iron, aluminium, all these atoms, aluminium is group 3, can lose electron, iron can lose electron, zinc can lose electron. So all these have a tendency to lose electron, so they are very good tendency to lose electron, hence they are very good strong reducing agents. So this is the way you can, from the periodic table, from the rule of octet, you can come to the reducing agents. So then what more? Now all electropositive elements, so or then those substances which can donate electron, those substances which can donate electron are also can be good reducing agents. Those substances which can donate electron, they can be so who donate electron? Now the Lewis base. The Lewis base, those have a lone pair of electron. Those have a lone pair of electron, they are very good reducing agents. So the substances have been capable of losing electron. Means if they have a lone pair of electron, unshared pair of electron, they can also donate electron. For example, ammonia is a very good reducing agent. Ammonia, what is ammonia? Nitrogen is combined with the 3 hydrogens covalently and has a pair of electron. It can donate this pair of electron. It can donate this pair of electron. So is ammonia. Somebody ask you that what is ammonia? Explain the chemical property of ammonia or chemical characteristics of ammonia. One will say ammonia is a base. Ammonia is soluble in water. By a student standing there will say that ammonia is a very good reducing agent. Then why? Now because addition of electron is reduction. Reducing agent is one which brings out reduction. So those substances which can contribute electron are reducing agents, and ammonia has an unshared pair of electron, it can easily give. So you see, and then he will ask, please explain, then give an example. Now you see here you have ammonia. We have ammonia here. We have ammonia here, lone pair of electron, and we have H plus. What is H plus? Is an oxidizing agent. Why oxidizing agent? It can accept electron. It can accept an electron. I have explained you just now. Explain electron. So this donate a pair of electron. This donates a pair of electron to H plus, and it forms ammonium ion. It forms ammonium ion. We have read in your school this property, and it forms an ammonium ion. Electropositive compound radical. Electropositive compound radical. So this is what a base, and this is an acid, you can say, and this is an reducing agent Ra, and this is an oxidizing agent OA. This can accept electron, this can give electron. So there is no oxygen, there is no hydrogen, but the reaction is taking place. So we'll say substances which are capable of this. Now if you come to another example I can give you here, this is a very good example. You are explaining ammonia is an oxidizing agent, reducing agent, H plus is an oxidizing agent. Because those who can accept electron, what is oxidation? The loss of electron. So who brings out oxidation? The oxidizing agent. So the electron lost will be accepted by whom? By the oxidizing agent. So H plus can accept electron, an oxidizing agent. Ammonia is a reducing agent. So you see, if you go by this, whatever knowledge you are learning in a class, apply it. That is called skill questions. That is called skill questions. Any entrance exam you appear, and if you have a very good understanding of chemistry, I can assure you children, you will come with 100%. But a student who remembers everything and goes may forget everything in the exam, because question will not come from his memory. Questions will come from his skill application. Skill application can then be possible that when you have your knowledge, applying it. So whatever you have to increase your thought power. So whatever you learned, try to apply it so that you will enhance your knowledge and you will be learning things. So now we'll come to the reducing agent. You see, hydrogen peroxide you have done as a reduce. Now I will thinking two compounds I am taking here. Suppose I have taken sulfur dioxide. I told reducing agent. I have H2S. This is also reducing agent. Sulfur dioxide is a reducing agent. We have done this. Hydrogen sulfide is a reducing agent. But when sulfur dioxide and H2S come, one will be an oxidizing agent and other will be a reducing agent. Hydrogen sulfide is a reducing agent. Sulfur dioxide is a reducing agent. But when you come to sulfur dioxide and H2S, sulfur dioxide acts as an oxidizing agent and H2S acts as a reducing agent. Sulfur dioxide has a tendency to act as an oxidizing agent. Hydrogen sulfide will have a tendency to act as a reducing agent. So this acts here in presence of, so one becomes an oxidizing agent or reducing agent depending on the other. Both are reducing. Sulfur dioxide reducing. How you write? I wrote the equation. Sulfur dioxide plus 2 water, and it produces H2SO4 plus 2H. So sulfur dioxide reducing agent I told you. H2S forms sulfur and 2H. Somebody may question why sir 2H. Now sulfur in sulfur H2S sulfide is -2. Oxidation number. It is gone. Gone माने कौन है? गोटे जिनस को आमे compress कर दीचु. Minus माने कौन है? Decreased, compressed. If you compress something, it will try to come up. It will try to come up. To allow try to come up. So in H2S, sulfur is an sulfide, and sulfur element it will come to 0. So sulfur has a tendency to become 0, and will become 0 when we can lose 2H. So between, if you compare these two, who is more reducing? Now H2S is more reducing. Because if water is not there, sulfur dioxide cannot be a reducing agent. Water is not there, sulfur dioxide cannot be a reducing agent. Why? In aqueous medium, it reacts to form water, a sulfuric acid, and loses 2 hydrogen. So who is more reducing? Now H2S. Because of this reason we learn H2S is more reducing than sulfur dioxide. So sulfur dioxide is capable of what? Becoming an oxidizing agent here. So if you come to this H2S produces 2 nascent hydrogen and sulfur, and these 2 nascent hydrogen, they come out, you have sulfur dioxide plus 2H, you will have, this will form sulfur plus water. Sulfur dioxide will react, this hydrogen will now come, this hydrogen which produced will reduce sulfur dioxide. So how many oxygen are here? 2 oxygen. So you have 2 hydrogen. 2 hydrogen balanced. So how many hydrogen here? 4 hydrogen. How many hydrogen you will make it? 4 hydrogen. So how many hydrogen coming out? 2 hydrogen. So you will multiply by 2. So we will write the equation here. Sulfur this H and H will cancel. We will get SO2, 2H2S, 2H2S plus SO2 forms here 3S plus 2 water. So this H2S is a reducing agent and sulfur dioxide is an oxidizing agent. So this sulfur dioxide has become sulfur. So in sulfur dioxide, what is oxidation number of sulfur? It has become sulfur. So it was +4, it becomes 0. Decrease of oxidation number is reduction, and you will have H2S. This become, it was -2, this becomes 0. So increase of oxidation number is oxidation. So we'll now, from the oxidation number knowledge, you see you are explaining one is a reducing agent and other is oxidizing agent. So because sulfur is in +4 state, in which state sulfur is? +4 state in sulfur dioxide, and which sulfur is as a -2 state. So one is compressed and other is a higher state. So the higher state will try to come down and lower state will come up. Always if you compress something, it will come up. So S -2 will become 0 easily and sulfur dioxide will come to decrease from to 0. So it is becoming 0, it is become 0. So these reactions are called as these. You have H2S, sulfur dioxide, and H2S is also becoming sulfur. So hydrogen sulfide reduces sulfur dioxide to become sulfur, and sulfur dioxide oxidizes H2S to become sulfur. In this reaction, what will you say here? What will you say in this reaction? Sulfur dioxide oxidizes H2S to sulfur and gets reduced to sulfur. So in this case, H2S to sulfur is reduction, and sulfur dioxide to sulfur, H2S to sulfur, H2S to sulfur is oxidation. Sorry, I am just one mistake I have done here. So H2S to sulfur is oxidation. Why? It is -2, it becomes 0, oxidation. And sulfur dioxide to sulfur is what? Reduction. Is what? Reduction. So in the same reaction, you have oxidation and reduction simultaneously. So these reactions are called as redox. So such reactions are called as redox reactions. Now we'll come to what is a redox reaction. So that will come later on. Just let me talk to you more about reducing agents. Who are reducing agents? Now the hydra acids are very good reducing agents. Hydra acids. Who are they? Now HBr is a reducing agent. HI is a reducing agent. HCl is a reducing agent. Why? This can give H, this can give H, this can give H. The reducing agent. H2S is a reducing agent. HCN is a reducing agent. All these are very good reducing agents because the hydro acids, they are reducing agents. They can give H. You can get H from them. We have done the reaction. When I was showing you the reaction, concerned sulfuric acid with potassium bromide. I gave you concerned sulfuric acid with potassium iodide. I have shown you the reaction. So those they are very good reducing agents. Then suppose somebody put a question that nascent hydrogen brings out redoxin. Explain. Question will come to you from this reducing agent. A question may come to skill question will come to you. Nascent hydrogen is a reducing agent. Then one will say, sir, addition of hydrogen is reduction. So nascent hydrogen is added, hence reduction. So hence hydrogen is reduced. I don't want that. I want to prove that he has stolen things. Have you seen? No, I have not seen. Are you seeing hydrogen is reducing? No, I am not able to see, sir. I am not seeing hydrogen. How can I see reducing? Then how do you say? You have not seen it. Justify. Logic. Then comes when you cannot see something, you will go by what? Logic. Logic. By argument. By evidence. We always prove a fact. When a fact is not known, we collect evidence. And all the evidences, when they come in support of the thought, our thought, then our thought is correct and it becomes a fact and truth, and then goes everything all right. So here we are, what is our question? The nascent hydrogen is a reducing agent. Nascent hydrogen is what? It has one electron in its outermost cell. This question is what? The question is nascent hydrogen is a reducing agent because the addition of hydrogen is a reduction. So now the same first thing came as a question, prove that nascent hydrogen is a reducing agent. What is nascent hydrogen? One electron. So hydrogen, next in that gas, the atoms of every element have a strong tendency to attain octet or nearest inert gas configuration either by losing or by gaining electron. So hydrogen will have a strong tendency also to accept one electron to become helium. So hydrogen takes the electron and forms H minus. Happens. So this is the electron, this process you are getting it. So it is a reducing agent. So very easy for you people. So this is the way you can take, I can explain this, or you can say hydrogen, other way you can say hydrogen loses an electron to form H plus. You can say, go by this, hydrogen has one electron outermost cell, it can lose electron and form this. So if you have a substance A plus electron will become what? A minus. So this is reduced state. Who does it? Now the hydrogen did it. Who does it? This electron came from where? The electron came from hydrogen. So nascent hydrogen is capable of losing an electron. Nascent hydrogen is capable of losing an electron. Capable of losing an electron, which can bring out reduction, hence nascent hydrogen is a reducing agent. Question will, what will your answer? The nascent hydrogen is what? An atomic hydrogen. Your answer is this. Nascent hydrogen is an atomic hydrogen. Has one electron in its outermost cell. So has a tendency to lose its electron to form H plus ion to become stable. So those substances which lose electron, they are reducing agent. Those substances which accept electron, oxidizing agent. The nascent hydrogen is losing electron. That electron is bringing out reduction, hence is a reducing agent. think, because once you know that addition of electron is reduction, loss of electron is oxidation, oxidizing agent brings out oxidation, reducing agent brings out reduction, so the electron comes from the reducing agent, so the hydrogen is capable of this. So sodium is a very good oxidizing agent. So sodium has electron configuration 281. So if it loses electron, this becomes Na plus electron. So 28. So this 28 is a neon structure. What is the structure of this? This is the structure of neon. So sodium has a strong tendency to lose electron. Strong tendency to lose electron. Hence it is a very good reducing agent. So sodium is used as reducing agent. So what is oxidizing agent? What is reducing agent? Explain. Now I will come to explain you what is a redox process, and now we will define redox process. That what is a redox process? Then we will come to give the examples. Redox process. Redox process or redox reactions. So those reactions in which oxidation and reduction take place simultaneously are called as redox reactions, or called as redox reactions or redox process. Those reactions in which oxidation and reduction, oxidation is going on, reduction is also going on, simultaneously both are taking place, hence we will call the reaction as redox reaction, redox process. So what is this? Now how will you say every oxidation or every reduction reaction involves the redox process? What is oxidizing? Oxidizing agent brings out oxidation, gets reduced during the process. So during oxidation, reduction of oxidizing agent takes place. Hence every oxidation reaction involves a redox reaction. If you come to reducing agent is one which brings out reduction and gets oxidized. So during reduction, oxidation of reducing agent takes place. So every reduction reaction also involves a redox reaction. So that is the reason oxidation and reduction always take place simultaneously. If you have an object, you have a shadow, provided you have a source of light. If you have a source of light, every object has its shadow. Every object has shadow, provided you have a light. Exactly same thing here. If every oxidation is going on, reduction is going on, oxidation is going on. So those reactions in which oxidation and reduction take place simultaneously are called as redox process. So what will I write here? I will say that oxidizing agent is one. Oxidizing agent brings out oxidation. Brings out oxidation and gets reduced during the process. So during oxidation, reduction of oxidizing agent takes place. Hence oxidation and reduction takes place simultaneously. Where there is oxidation, there is reduction. That is where there is a birth, there is a death. Only time will come. So that process, life is the process. So oxidizing agent brings out oxidation and gets reduced during the process. So during oxidation, reduction of oxidizing agent takes place, hence oxidation and reduction takes place simultaneously. Now if you come to reduction, reducing agent is 1. If you come to the reduction, reduce same way, the equation, the reducing agent is 1 which brings out reduction, which brings out reduction and gets oxidized during the process. So during reduction, oxidation of reducing agent takes place. Hence, where there is reduction, there is oxidation. So where there is oxidation, there is reduction. Where there is reduction, there is oxidation. So we can say, so oxidation and reduction take place simultaneously. This will make question simultaneously. So where there is oxidation, there is reduction. Where there is reduction, there is oxidation. So hence oxidation and reduction takes place simultaneously. I am giving a simple example here. I have seen, so as you see, I gave the example just now, sulfur dioxide plus 2H2S. It forms 3S. You have water, 2 water and 3S. We did the reaction now. So in H2S, this is -2 and this is becoming 0. So this reaction, decrease of oxidation, increase, here oxidation number is increasing. So this is oxidation. Now in sulfur dioxide, oxidation number of sulfur is +4 and that is 0. And this is reduction. +4, 0, this is reduction. So in this reaction, sulfur dioxide is reduced to sulfur and H2S is oxidized to sulfur. In this reaction, sulfur dioxide is reduced to sulfur and H2S is oxidized to sulfur. So sulfur dioxide reduced to sulfur. Who got in sulfur dioxide? Sulfur is reduced to sulfur and in H2S sulfur is oxidized to sulfur. So this is an example of redox process. Hence this reaction. So this is a reaction, oxidation of H2S and reduction of SO2 simultaneously taking place. Hence this is an example of redox process. So those reactions, oxidation, reduction take place simultaneously. They are called as redox reactions. Where there is oxidation, there is reduction. Generally, question comes to a student, explain oxidation, reduction take place simultaneously. Instead of asking what is redox process, one can explain oxidation, reduction takes place simultaneously. So you say what oxidation, say reduction, give an example, you can see. Same one more example, just I am writing it. Next class I will explain you many reactions like this. FeCl3 plus SnCl2. forms FeCl2 plus essential 4. You have your 6 so you have here 2. Now you multiply this by 2, so this becomes 4, multiply this becomes 8, so 4 plus, so stannous is becomes tannic plus 4 is a stannous plus 2, and this ferric chloride is becoming ferrous chloride. So ferrous is plus 2 and ferric is plus 3. Okay, so if you multiply this by 2 FeCl3, 6, and if you multiply this by 2, 4 and 8, so it will become the 6 plus 8. So balance equation. So ferric chloride is reduced to ferrous chloride, stannous chloride is oxidized to stannic chloride, but it will stay stannous chloride. SnCl2 oxidizes, reduces ferric chloride to chloride and gets oxidized to stannic chloride. So this is an example of redox process. So ferric chloride to ferrous chloride is reduction. This is reduction, and stannous chloride to stannic chloride is oxidation. So this is an example of redox process. So in this reaction, children, stannous chloride is a reducing agent, reduces ferric chloride to ferrous chloride and gets oxidized to stannic chloride. Hence, we say that in this reaction, reduction of ferric chloride to ferrous chloride and oxidation of stannous chloride to stannic chloride take place. Hence, this is an example of redox process. So this is oxidation reduction taking place simultaneously. Here oxidation reduction taking place simultaneously. Every oxidation is a redox process. Every reduction reaction is a redox process, and we have to evaluate only by knowing oxidation number. We can say which is oxidation, which is reduction. So next class I will talk to you more of redox reactions, and we will try to balance the redox reactions by ion electron method. Thank you so much for your listening so patiently.